Hello, welcome back to Mastering Statistics. Here we're finally going to use Microsoft Excel to solve this exact same problem that we have done, and then later on we'll solve a few additional problems. We have the age of different females getting married in these different states. We have the data that we've collected in each one of these states, and we're trying to do this Anova test at a 0.1 level of significance. So we're just trying to see if the population means for each of these states of the age of people that get married, women that get married, if they're the same or not, basically. So what you want to go ahead and do first of all is you go to the Data tab up here. And the Data tab on the right, you notice I have a Data Analysis button. Now you might not have that initially, and this is a Microsoft Excel 2013, I think it is. But anyway, this was not here whenever I started. You have to install it. So if you don't see it there, just go to Google and type in how to install Data Analysis Tool Pack for Microsoft Excel. Basically, you just go into one of these menus, click a few buttons, and then it'll pop up there. It doesn't cost anything. So just go ahead and enable it and you'll see it there. Then you want to go and highlight your data. These are the raw data that you're going to do, and then you hit Data Analysis, and what you want to select is Anova Single Factor. We're doing a single factor Anova because the only factor involved here is the location of the population. Basically, that's the only control or the only thing that's different there. So you go ahead and hit OK, and a dialog box pops up, and it's asking you for the input range of the data there. Now you need to click that button and highlight and select all of the data, and if you have labels at the top, go ahead and select that too. Click this to force it to accept, and your data is grouped by columns, which means the data for the populations goes down, and you have labels, in my case labels in the first row, and it's asking you for alpha, so you want 0.1. That's your level of significance for your problem. It's going to dump the output, in this case into a new worksheet, but you have some different options there if you'd like, and then you just literally hit OK, and then it calculates the answer. There you go. Let me go and zoom a little bit. We'll go to View, Zoom, and I'll set the zoom at 145 so you can see it a little bit better. All right, so here you go, Anova single factor. This is what all of that work that we did, pages and pages of calculations of all of that data has been reduced down to about 5 seconds, where you can see the fruits of it all. Basically what you have at the very top, this is the actual conclusion down here, and we'll talk about that here in just a second, but up at the top it gives you some additional data. First of all, it tells you that New York, which was the data in the first column, had 10 samples. When you add them all up, it was 201, and when you divide that by 10, it's 20.1. So it's giving you the sample mean. This is the sample mean right here, and then it's also calculating the variance of the data inside of that set of samples, right, which we were doing manually earlier. And then it does the same thing for Texas, how many samples and their average. This is the sample mean. This is the most important thing from there. And Oregon's sample mean. So basically the idea is Anova is trying to say, hey, for these different states, these are the different sample means. And obviously it looks like Texas is a little bit different. But statistically, is this enough to say that one of these states' population means of the age of marriage is enough, is actually strong enough? Is it strong enough to say that that we accept or reject that null hypothesis? So here's the difference here. Here's the answer, and this is very similar to the Anova table that we created by hand. So you have source of variation. Now the only real difference in Excel is that they use the word groups. They don't use treatments, the word treatments. Most textbooks use the word treatments, but I also told you that they can be called groups. So you have treatments, and then in Excel you call them groups. So you have SST, this is SST, sum of squares between groups, sum of squares among treatments, same thing. This is the number that we calculated before, and you can extend it out a little bit and see a few more decimals if you want. This is the same number over here. And then you have SSE, within groups. In fact, I kind of like these terms a little bit better because they're a little more descriptive. It's a source of variation. It's telling you between the different populations how much variation is there, and within each population how much error is there, how much spread is there. Basically, this guy is SST, this guy is SSE. When you add them together, you get the total variation, which is exactly what we had before. Then it just lists the degrees of freedom. We wrote those down in the table before, and that depends on the problem you have, number of populations, number of samples that you have, and that's the total degrees of freedom. And then this is MST, or the mean square between groups, and this is the mean square